You know, have you ever actually stopped to think about the invisible world all around us? I mean, the hidden systems that quietly keep the lights on in our homes, ensure our tap water is completely safe to drink, and make sure the trains are running exactly on schedule. We literally never think about them until they fail, right? But behind the scenes of modern society, there is this vast, super complex web of industrial technology. So, welcome to This Explainer. Today, we're going to explore the absolutely fascinating and frankly highly critical world of securing our industrial infrastructure. And we're basing this on some incredible insights and frameworks from the cybersecurity experts over at LumiVerse Solutions.
Okay, here's our roadmap for the explainer today. We'll hit 1. The systems powering our world. 2. Anatomy of industrial control. 3. Rising industrial cyber threats. 4. Real-world security incidents. 5. Defending with security assessments. And 6. The future of threat detection. Don't worry if those sound like intimidating acronyms right now. We're going to break it all down into a super clear journey from the basic definitions all the way to actionable security solutions.
Okay, let's dive into this. Section 1. The systems powering our world. What exactly runs the modern world?
So at the very top level, we have SCADA. That stands for Supervisory Control and Data Acquisition. You can kind of think of SCADA as the grand overseer of the operation. These systems are specifically designed to gather data in real time from really remote locations. They basically allow operators to monitor physical conditions and control massive pieces of equipment right from a central hub. It's almost like the ultimate remote control for giant infrastructure. Oh, and fun fact, variations of these systems have actually been around since the 1970s, which is way before the internet as we know it even existed.
Now, building right underneath that SCADA umbrella, we have ICS, or Industrial Control Systems. While SCADA is often that broad supervisory layer we just talked about, ICS is the collection of specific control systems doing the actual heavy lifting of industrial automation. This includes things like distributed control systems and programmable logic controllers, or PLCs for short. These are the highly specialized computers that actually drive the physical automation. They're the ones literally telling a valve to shut or a motor to spin.
Let's ground this in reality for a second, just to put it into perspective. If you turned on a light, drank a glass of tap water, or rode a train today, you relied entirely on these technologies functioning perfectly. I mean, the energy sector relies on these systems for power generation and distributing a stable electricity supply to your house. Water treatment plants, they use SCADA to monitor water quality and control the whole purification process. Over at manufacturing, ICS automates complex production lines to cut down on human error. And our transportation networks absolutely depend on them for traffic management and railway signaling. It's basically the whole shebang of modern life.
Moving right along to Section 2. Anatomy of Industrial Control, the Digital Nervous System.
So data flows through these systems in a really logical way. Think of it like a human body. Step 1. Sensors act as the nerve endings. They collect raw data from physical processes, things like temperature or pressure. Then Step 2. Communication networks transmit that data, essentially acting as the spinal cord. Step 3. The control systems serve as the brain, analyzing that data and responding in real time. And finally, Step 4. Human-machine interfaces, or HMIs for short. These provide a digital dashboard where human operators can actually interact with the system, monitor the performance, and make critical adjustments. It's this beautiful, seamless loop of constant communication.
But here's where things get a bit more serious. Section 3. Rising Industrial Cyber Threats, from high efficiency to high vulnerability.
Historically, protecting critical infrastructure basically just meant physical security. We're talking tall fences, security guards, protecting against physical disruption, or maybe just manual human error. But today, the threat landscape completely bypasses those fences. Now we're dealing with unsecured remote access, misconfigured systems, and outdated software acting as literally open doors. And the attackers? Well, they're using customized malware, ransomware, phishing, and APTs, advanced persistent threats, that are specifically designed to target industrial systems. I mean, let's face it, a chain-link fence simply doesn't stop malware.
Which brings us to Section 4, Real-World Security Incidents when Theory Becomes Reality.
And sadly, these vulnerabilities are not just theoretical exercises. They've been exploited with devastating effect. Back in 2010, there was the infamous Stuxnet worm. This malware specifically targeted Iran's nuclear facilities, and it crossed a massive boundary from just being digital code to causing actual physical disruption. It physically spun nearly 1,000 centrifuges until they literally tore themselves apart. Crazy, right? Then, fast forward to 2015, highly sophisticated malware breached the power grid in Ukraine, plunging over 200,000 civilians into the dark in the middle of winter.
these aren't just standard data breaches. They are actual real-world physical events triggered by digital attacks.
As the experts at LumiVerse Solutions put it, quote, "These incidents demonstrate the potential impact of cyber attacks on critical infrastructure and the need for strong security measures to protect SCADA and ICS systems. We really need to let that sink in. The financial, reputational, and public safety costs of these breaches are simply way too high to ignore. We absolutely cannot rely on outdated defenses anymore."
So what do we do about it? Section 5, Defending with Security Assessments, the framework for protection.
How do cybersecurity experts actually tackle this? Well, LumiVerse Solutions breaks it down systematically, and this brilliantly illustrates how specific assessment types map directly to actionable outcomes. First up, vulnerability assessments. Think of this as a routine health checkup for your network. Comprehensive scans to detect weaknesses early, mitigating risks long before bad actors can exploit them. Then there's penetration testing. This is the stress test. Testers use advanced tools to simulate real attacks and exploit flaws to see exactly what breaks, which reveals the true potential impact of a breach. Finally, security audits. These act as your compliance baseline, ensuring you're actually meeting strict, essential standards like ISO 27001, GDPR, and NIST.
The absolutely crucial takeaway here is that a single layer of security is no longer viable. The overarching philosophy we need is a defense-in-depth strategy. Actually, what this means is intentionally layering multiple security controls. It's like if an attacker somehow picks the lock on the front door, they immediately trip an alarm in the hallway. By combining network segmentation, really strict access controls, continuous monitoring, and intrusion detection systems, organizations can vastly minimize the impact of potential breaches and ensure they stay operational no matter what.
Looking ahead, Section 6, The Future of Threat Detection, Evolving Defenses.
The reality is, manual monitoring alone just isn't going to cut it anymore. The future of defense relies heavily on artificial intelligence and machine learning. And look, these aren't just trendy buzzwords, they are absolute game changers. These tools analyze massive amounts of network data instantly, spotting abnormal patterns the exact second they occur. Instead of waiting for a human operator to notice something and hit an emergency stop, these AI systems can trigger automated, real-time responses to lock down threats. It drastically reduces the need for manual intervention, which is completely necessary for organizations trying to keep up with an ever-changing web of government regulations around critical infrastructure. So, what does this all mean for us? We've seen how absolutely vital these invisible SCADA and ICS networks are to our everyday lives, and we've explored the sophisticated frameworks required to protect them. As AI continues to revolutionize both the threats to our industries and the defenses we use to fight them, and as regulations rapidly evolve to keep pace, is your critical infrastructure truly prepared for tomorrow's attacks? It's a question every single organization relying on industrial control must answer. Thank you so much for joining me for this explainer. Keep learning and